White Sands, New Mexico, a 5,000 square mile tract of barren, sun-baked wasteland 60 miles to the north of El Paso, Texas. Lost in the vastness of the desert is a clump of low-lying buildings where the United States Army Ordnance Department is conducting a research program for long-range rockets and guided missiles. In one of these buildings, the once dreaded German V-2 rocket is assembled and prepared for launching by ordnance men. No longer a weapon of war, the V-2 is doing an important post-war job in cosmic research. The missiles which rain death and destruction on the English countryside are sent 100 miles into the upper atmosphere at White Sands. Farther than any human can penetrate, instruments record data on cosmic radiation, sky brightness, direction and speed of wind, and many other aspects of high-altitude research. Here is the assembly line. With the exception of special attachments that are manufactured in this country, the entire missile is constructed from parts made by the Germans before VE Day. Every detail of the Nazis' most closely guarded secret weapon is known to American technicians. Glass wool insulation prevents the evaporation of fuel from the center section. With insulation in place, a tank for alcohol is lowered into the center shell. To the rear of the alcohol tank is a tank which will hold liquid oxygen. The supply line, which will carry alcohol to the rocket motor, runs through the center of the oxygen tank. The alcohol supply connection is completed, and the oxygen tank is moved into position. With the fuel tank secure, the center section skins are fitted. A metal fairing joins the halves of the shell. As a further precaution against evaporation of fuel, the ends of the shell are packed with glass wool, and metal bulkheads are installed to complete the assembly of the center section. This section is the basic component of the missile. Other sections will be attached to it as they are completed. Meanwhile, the propulsion unit is being assembled. Its principal part is the welded, pressed steel combustion chamber. Pre-formed fuel lines are fitted to the combustion chamber. Liquid oxygen and alcohol are drawn from the fuel tanks and forced into the combustion chamber by a centrifugal pump. The turbine of the fuel pump is driven by steam, generated by the violent reaction of hydrogen peroxide and sodium permanganate. When the propulsion unit has been fully assembled and inspected, it is placed on an assembly jig and fitted to the center section of the missile. Specially constructed frames which roll on tracks aid in the assembly. Inside the tail housing, electrical wiring for the rudder mechanism has been installed. Now, with the propulsion unit secured to the center section, the tail housing is pushed into position. The propulsion unit of the V-2 rocket burns a mixture of liquid oxygen and alcohol. These fuels are forced into the combustion chamber through a bank of 18 jets. On the thrust ring at the base of the tail unit are 4 brackets to which carbon vanes will be attached. These vanes, controlled by an automatic pilot, direct the flow of gases from the venturi and steer the rocket during the burning period. They are attached after the missile has been erected for launching to prevent breakage and handling. The antennas for radio devices that relay high-altitude data to ground stations are located at the bases of 2 of the fins. While on the other fins, there are antennas for an emergency fuel cutoff mechanism. Instruments replace the explosives in the V-2 warhead. They are designed especially for each missile by the agency for whom the rocket is fired. Most of the recording instruments and telemetering devices are placed in the warhead, although some go into the control compartment between the warhead and the fuel tanks, which also contains the electrical controls that guide the rocket. When the missile is completely assembled, it is weighed and its center of gravity is determined. Without fuel, the rocket weighs 5 tons. The addition of 9 tons of alcohol and liquid oxygen brings the gross takeoff weight to approximately 14 tons. When the rocket is ready to be taken to the firing range, it is placed on a special vehicle called the Milowagon, designed for carrying and erecting the missile. Extreme care is taken in transporting the missile from the assembly area to the firing range. The delicate control mechanism of the rocket is very easily damaged. A maximum speed of 20 miles an hour is maintained on the 5-mile trip. Trailers carrying equipment used by the ground launching crew follow the rocket. The men of the ground crew are soldiers from the 1st Anti-Aircraft Guided Missiles Battalion. A launching platform is brought into position to be engaged to the Milowagon. Retaining clamps, which hold the missile to the lifting frame, are checked, and mechanical jacks are employed to level the launching platform. A wooden working stage, which will be removed before launching, is placed over the blast deflector before erecting the rocket. The missile is ready to be raised to a vertical position. Hydraulic rams on the Milowagon are set in operation. The missile is not anchored to the platform in any way. Therefore, care must be taken to seat the rocket squarely. With the rocket firmly seated, the retaining clamps on the lifting frame are released and the frame is lowered. While the V-2 is being erected on its platform, technicians are busy